Today we are going to focus on unit rates and also rates and really just the difference between those two. So we did an activity yesterday called What's Your Rate, where we found the number of jumping jacks we could do in 1 minute, the number of times we could say the alphabet in 1 minute, and the number of push-ups we could do in 1 minute. So we were finding our unit rates, then we calculated different rates. So a rate is a type of ratio, but it is using two different units, like jumping jacks compared to minutes. But a unit rate specifically compares a quantity to 1 unit, so just comparing it to 1 specifically. Then equivalent rates are going to have the same unit rate, so we can always get them down to the same unit rate. Here's a visual example of these things. So if you were to go to the grocery store and buy this bundle of cereal, these 3 boxes are $12, so your rate is $12 for 3 boxes. Then if we were to divide that down, the unit rate is $4 for 1 box. Okay, so if we go down here, we have a double number line that shows the rate at which you earn points for successfully hitting notes in a music video game. Write a rate that represents this situation. Well, right here, I'm getting 150 points per note. That is my unit rate. But if I wanted to write a rate, I could use any of these other comparisons. So I could say 300 points for every 2 notes, 450 points for every 3 notes. So in this specific double number line, there are 4 other options. Go ahead and write a rate here. And then all of those would be considered equivalent rates. All right, next up we have a piece of space junk that travels 5 miles in 8 seconds. We're going to figure out how far does it travel per second. So here's our ratio, 5 miles, 8 seconds, that's our rate. We are going to use a ratio table for this. And we'll divide by 8 because it's 8 seconds to get an equivalent rate where the time is just 1 second. So we're trying to get it down to the unit rate. So first thing we're going to do is set up a ratio table. We're looking at distance, which is being measured in miles. And we're looking at the time, being measured in seconds. Okay, so you can just use your ID as a straight edge to make your T-chart here. Okay. It doesn't matter how big the ratio table is. Then we're going to fill in what we know. 5 miles, 8 seconds. Okay, we're trying to get this down to 1 second. That's our unit rate. So to do that, we've already established that we need to divide by 8. So then I need to go up here and divide by 8. Okay, now here's the thing. If I take 5 divided by 8, we are going to end up with a decimal number. However, we know that fractions are just division problems. So I'm going to write 5 divided by 8, and I'm just going to leave it at that. If I have 5/8 of a mile, that's just over half a mile. So I can say it travels 5/8 of a mile per second. All right, flip this over. Hey, we're going to look at another scenario using price. So instead of distance now, we're going to look at price. So we have a chef that buys 6 pounds of salmon fillets for $51. We want to know how much the chef is going to pay for 9 more pounds. So I've highlighted my important information. I'm going to put a box around the question here. Okay, and then we're going to use a ratio table again, and we'll divide down to the unit rate and then multiply to get the cost of 9 pounds. So what we're looking at is the cost, okay, which is being measured in dollars, and then we have the salmon, which is being measured in pounds. Okay, we're going to set up our T-chart here. I'm just using my ID as a straight edge since we all have one. Okay. And then we'll look at what we know. 6 pounds of salmon is $51. 6 pounds, $51. So what you're going to do is you're going to get the unit rate by dividing down to 1. Then you're going to multiply to get to 9 pounds. Go ahead and pause your video and figure out what the cost of 1 pound of salmon would be. Okay, so if we did our long division out to the side, that means 1 pound of salmon is $8.50. It makes sense to use decimals in this scenario because we're working with money. Okay, so I divided by 6 here. So I divided by 6 here. Now we need to figure out how much 9 pounds is going to cost. So I'm going to multiply by 9 and then multiply by 9. Go ahead and pause your video and see what the cost for 9 pounds would be. Okay, so 8 5/10 times 9, the chef will pay $76.50 for 9 more pounds. Okay, one more problem down here. So this time we're looking at tilapia fillets, so just a different type of fish. So here's our rate. You buy 2 pounds of tilapia fillets for $16. We want to figure out the cost of 7 pounds. So here's the question that we need to answer in a complete sentence. We can easily divide 16 into halves, fourths, eighths, and you could probably look at this and figure out the unit rate with this one. There's no decimals, but we're going to model this and show our work using a double number line. This will give you plenty of examples to utilize as you work on your take-home test. So what we're comparing is the tilapia in pounds to the cost in dollars, but we're going to go ahead and set up the double number line for that. So that's where we make the vertical line. And then my 2 number lines. Doesn't matter how far apart they are. We're going to say 0, 0 to start because if I buy 0 pounds, it's $0. If I spend $0, I'm going to get 0 pounds. So then let's fill in what we know. 2 pounds of tilapia is $16. And what we're trying to get to is 7 pounds. Okay, so we cannot easily, without using decimals, get from 2 to 7. So this is where it's helpful to go down to the unit rate. So if I go down to the unit rate and I figure out how much 1 pound costs, well, 2 divided by 2 gets me here. So I'm going to go do 16 divided by 2 up here to get 8. So now that I've done that, I can take 1, and I'm going to get up to 7, so I can take 1 times 7, and then do 8 times 7. So go ahead and fill in that box and write your complete sentence as well. All right. The cost for 7 pounds is $56.